Hello everyone. So welcome back to the good stuff we've been doing. Here we're going to continue with trigonometric functions. In the previous video, what we did was that we introduced the concept of the hypotenuse, the adjacent, and the opposite, where we labeled here A, here was B, and then this is our C. And then usually this is how we label it. No. So this is supposed to be C, this is supposed to be A, and then this is supposed to be B. It is not a law, just that it's always beautiful when we do it this way. So what we're going to introduce here today is the trigonometric functions. And the first of them is the sine. Now this sine, it's always in terms of an angle. Let's say in this our triangle here, we have this angle to be theta. Let's see, this angle A part to be theta. Okay, so let's now see what the sine theta says. Sine of theta, the sine of the angle is equals to the ratio of the opposite side all over the ratio of the hypotenuse. And if you look at this angle theta, the opposite side will be A and the hypotenuse will be C. Kind of like, suppose you have a numerical values given to this triangle. Let's say this is your let's say this is your angle 90 degree, and then here you have, say here is 3, and then here is 7, and this is theta. Then what this means is that sine, let's say sine theta, this theta here is equals to 3/7. That is, the sine of this angle here is equal to the ratio of the opposite side here all over hypotenuse side here. This is that the reason I chose 3 for this side and 7 here is that I cannot just write 7 here and write 3 here, even though I'm just giving an example. The reason being that it will not be correct. Why will it not be correct? If I go on and write 7 here and then here is 3, I would be, it will seem that this side here, which is 3, is now smaller than this third side, and this is not true. For any triangle, the hypotenuse is always the longer side. So with sense, I just pick 3 here and then 7 here. That is how it should be. So sine theta is 3/7. So that is just an illustration, but moreover, it's not just an illustration. We'll come back to this. There is a very useful fact embedded in this. So let me clear this off the board. Okay, so let me use the eraser for this part. Now let's go back to our discussion. The sine was defined as the ratio of the opposite side all over the hypotenuse side, and that was A/C. On the other hand, the cosine of the angle theta is equals to the ratio of the adjacent side over the ratio of the hypotenuse, and this here adjacent is B all over C. And then finally we have the tangent, and they will define this as the ratio of the opposite over the hypotenuse, and this is equals to A/B. We have explained how we got to know about opposite and hypotenuse in the previous videos. Now there are other trigonometric functions, like one of them is the cosecant. This cosecant equals 1 over sine theta, and then we have the secant, which is 1 over cos theta, and then we have the tangent, tan theta, no, not the tangent, the cotangent, to be equal to 1 over tan theta. But we'll come back to these ones probably in future videos. For now, we don't really need them, especially for those who are preparing for WAEC. We will not bother with this for now, just to show that some of this exists. This 3, the reason for now is that this 3 is enough problem for us. There's no point in compounding the whole issue. This 3 will do us for now. So we have tan theta to be equals to opposite over hypotenuse, which is A/B. Now another thing we can notice here is that, let's say this is angle alpha here, okay, and that angle is alpha. Now let us try to do one thing. If supposing that we try to look at alpha as our point of reference, we'll be having sine alpha to be equal to the ratio of the opposite, which is the b, all over the hypotenuse, which is c, and then the cos alpha would then give us the ratio of the adjacent, which is a, all over the opposite, which is c. But then if you notice that here now, this is a over c and this is likewise a over c. So what that tells us in actual is that we have that, how do I put this? Okay, let me put it this side. What that tells us is that sine theta is equals to cos alpha. That is what we know. But then alpha, notice that alpha is just if you take 90 degree and you remove theta, because if you add alpha and theta you get 90 degrees, so alpha is 90 degree minus theta. So this means that sine theta is same thing as cos 90 degree minus theta. And likewise, if you notice here as well that this is b over c, and likewise for the case of this cos, so b over c. All right, no, okay, yeah, like, okay, so this is b over c and this is, so this cos sine alpha is cos theta. So let's write it down. So sine alpha equals cos theta. Now that should tell us that sine 90 degree minus theta is just something as cos theta. Okay, wait. So sine 90 degree minus theta is something as cos theta. Now the reason for this identity is that if you have sine 90 degree minus 15 degree, this is equals to cos. This is equals to cos 15 degree, because we say sine 90 degree minus theta is cos theta, so this is equals to cos 15 degrees. What that should tell us is sine 75 degree is same thing as cos 15 degree. So here, if we know sine 75 degree, it should definitely be equal to cos 15 degree. Another thing we can notice here again is as well that since sine 90 degree minus 60 degree is equals to cos sine of 60 degree, so 90 minus 60 is 30, so therefore sine 30 is same thing as cos 60 degree. So this is an identity, like it shows that this relation is true for triangle. When you have cosine of this, you can simply find it for this. So if we know sine 30, we automatically know sine 60 based on this identity. So we have introduced the three trigonometric functions, which is the sine, the cosine, the tangent, and by definition sine is equals to the opposite of a hypotenuse. And you don't need to memorize any of the definition, because you can just simply use your SOHCAHTOA to just simply say sine is opposite of a hypotenuse, cosine is adjacent of a hypotenuse, and then tangent is opposite of a adjacent. That is it. And after that, so after we define the trigonometric functions, we simply stated that these relationships are true. Let's say sine theta is cos 90 degree minus theta, and we showed how we can use it practically. Like whenever we know sine 30, we already know cos 60. So thank you for watching this part of the video, and in the next part we are going to delve deeper into trigonometric identities. Thank you, and please subscribe to the channel. Have a nice day.